All right, should be on the back of 11.4. Let's do a couple of problems you're supposed to do us after homework. They might have tripped you up. Let's start with number 4. Sum from t equals 0 to 3 of 2t minus 3. So you're starting with 0, so it's 2 times 0 minus 3 plus 2 times 1 minus 3 plus 2 times 2 minus 3 plus 2 times 3 minus 3. This is just going to be negative 3 minus 1 plus 1 plus 3, and I get 0. Fair enough? Let's look at 6, because 6 is kind of fun. 6 is a sum from I equals 1 to infinity. First of all, you should be thinking, wait, how can I sum things to infinity? Actually, we know how. For one type of problems. What kind of problem is this? I might not know, but I might plug in some numbers and find out. I got 10 times a half plus 10 times a half squared plus 10 times a half to the third plus dot, dot, dot. Looking at that, that gives me 10 over 2 plus 10 over 4 plus 10 over 8 plus 10 over probably 16 plus dot, dot, dot. It's got to be geometric. The ratio is 1/2 between these two. It's 1/2 between the next two. It's 1/2 between the next two, is it not? So, sum of infinite series ratio is less than 1. So I'm going to go sum of infinite series, a1 over 1 minus r, which means the first term would be 5. That's what 10 over 2 is. 1 minus a half. So you get 5 over a half, which equals 5 times 2 over 1, which is 10. And so this would be equal to 10, despite its intimidating starting point. Fair enough? Take a look, see. All right. Now, that isn't the hard part of this worksheet. Here comes the fun part. The fun part is, how do I write a summation just given the numbers? If I give 26 plus 24 plus 22 plus 20 plus 18, how do I do this? Now, you guys are clever enough, you could figure out a way to do this without a formula. But I'm going to express to you kind of a way to do it with a formula, so therefore you don't have to come with something brand new every single time. Does that make sense? So, here we go. I keep saying, does that make sense if there's people in my room? There's nobody here. N equals 1, 1, 2, 3, 4, 5 terms, right? Now, what kind of series is this? It's going up by 2 each time, so this would be, hopefully everybody's in the room saying arithmetic. Probably half of you did not say that out loud. You should have. Press everybody. So here we go. So it's arithmetic, and I'm subtracting 2 each time, am I not? So how do I find the nth term? Well, I have a formula for that, right? It'd be a1 plus the common difference n minus 1. Agreed? So n equals 1 to 5. The first term is 26 plus the common difference is negative 2 times n, which is the number of terms, which is what is going to state a variable, minus 1. And again, if I want to, I could distribute this through 26 minus 2n plus 2. So I could rewrite this simplifying n equals 1 to 5, 28 minus 2n, and that's my series. Now, again, there's some people in this room right now saying, hey, I had a different way to do this. Yes, you did. Good job. Good job. But this is the way that works every time. If you notice it's arithmetic and you get a little confused, you can figure this out. And when things get more and more sideways, we're going to want these tools. So that's the first one, is arithmetic. What if it's geometric? Same exact game. So I've got 8 plus 4 plus 2 plus 1 plus a half. First of all, I check arithmetic. 4, negative 2, definitely not arithmetic. Then try the next thing, which is 4 over 8, which is 1/2. 1/2 times 4 gives me 2. 1/2 times 2 gives me 1. It's geometric. So I'm going to go sum from n equals 1 to how many terms? 1, 2, 3, 4, 5. I get 5 terms. And then I use my formula, which is A1 r to the n minus 1. First term is 8. The ratio is 1/2 n minus 1. And I'm good to go. So, not too bad, right? If you know your arithmetic, you know your geometric, you can go right to this and you get the right answer. What else could it be? Next one on our list is -2 plus -4 plus -12 plus -48. So I start off with my, all right, let's try arithmetic. I went down 2, I went down 8, not arithmetic. Let's try geometric. -4 divided by -2 is 2. 2 doesn't do that one. So then I try to find a pattern inside the pattern. What I mean by that is there's some sort of pattern that I'm missing. So I might try the next one, and I would notice that it's -36. Still don't see a ratio there. If I were to do this one, though, -12 over -4 is equal to 3, right? Because I'm checking the ratio. Now the ratio is not the same, but when I check the next one, I get -48 over -12, I get 4. And there's a pattern geometrically, but it's not just times 2 each time. So therefore, I can't just simply write the geometric formula down. If it goes up 1 every time, then it's a factorial. Even if it goes up 2 every time, it's going to be factorial. But let's start with just 1. So since the ratio is the same, since it's going up each time the same bit, you have to deal with a factorial. Now, some of you might not remember what a factorial is. Factorial is, 4 factorial, let's say, is equal to 4 times 3 times 2 times 1. 5 factorial is equal to 5 times 4 times 3 times 2 times 1. We use these typically in probability problems, but they also appear in calculus problems that are coming towards you at the speed of a turtle. So let's try these problems out. Let's take a look, see, and then we go, okay, so I'm going to do this. I'm going to write a factorial. Factorial. How do I figure out what the next term is? Well, I take a look and go, well, I had to multiply by 4 times 3 times 2. So that would be 4 factorial for the 4th term, 3 factorial for the 3rd term, 2 factorial for, and 1. So this is just n factorial, agreed? I'm pausing there again. So, but that doesn't solve the problem because that just tells me what I'm multiplying by each time, right? So 4 times 3 times 2 times 1, that's 24, that's not 48. So I got my sum, so n equals 1 to 4. How am I going to fix my factorial? Well, if I plug in a 1, I need it to be -2. It gives me 1. Put a -2 in front. Try it again. Put a 2 in there. 2 factorial is 2 times 1, which is 2. Times -2 gives me -4, and so on and so forth. And so I extract out the factorial and try to figure out what's left over to fix it. Are these easy? No. They're easier than what's about to follow. So let's try the next one. No, not the next one. Here it comes. 2 plus 2 plus 8/3 plus 4 plus 32/5 plus 32 thirds plus 128/7. And so I start to look at this and go, what? No way. No way this is going to make any sense at all. Can't possibly figure this one out. But I'm going to start anyways with my usual arithmetic 0. Next one is 2/3. No, not arithmetic. Try my geometric 1 4/3. Maybe let's check the next one. What happens there? I need to have, I can cancel out the 3, so I have 3 on top and a 2. So this is multiplying by 6. Anybody see a pattern? No. So then what we try to do is we try to find generalized rules for the top and bottom. And so I start looking for patterns that might be hidden from me. And so I might notice that I've got a 3 a 5, and a 7 sitting here. Which means, what is this thing? What if it was 6? So I'm going to try 128 over 7 plus, taking a look at this, starting to sweat, I go 64/6 plus, this one down here would be 32/5. Okay, that's okay. Ooh, I got to make this fourths. That would be 16/4 plus, now I try this one, it's got to be thirds. That's okay, it's already thirds. That's a good one. 2, I need to make this tooths, so it's going to be 4/2. And then I try the next one, and that's going to be 2/1. All right, now pausing there. My thinking was I saw the 7, I saw the 5, I saw the 3. Let's see if I can get the bottom pattern stand out. When I did that, I now have a separate pattern for the top and bottom. Cool. Sigma n equals 1, 1, 2, 3, 4, 5, 6, 7, right? So I got 7 terms. The bottom is easy. It's just n, right? For term number 1, it's 1. For term number 2, it's 2. For 3, it's 3. 4, it's 4. 5, 5. 6, 6. 7, 7. That's easy. What's the top? Ooh. 2, 4, 8, 6. This is geometric, so I can write a geometric series, which is a1 r to the n minus 1. So I'm going to clean this up. N equals 1 to 7. First term is 2 over, I still got my n on the bottom. And then my ratio is I'm multiplying by 2 every time. So that's 2 to the n minus 1. Probably should put some parentheses around that so it doesn't get confusing. If you want, you can put the 2 back in. It's really not necessary. This is good enough for our work. Oh yeah. So that's how you try to figure out how to write these sigma series. And if you can write the sigma series, that's helpful for where we're going. Okay. So, because this is going to be step 1 in a multi-step process, and some of you are shaking, it's going to get worse and then it's going to get better. Okay, so don't sweat it too badly, but we do need to start working on these. So, flip it over. You've got problems 7 through 14 to take a whack at. Okay, 7 through 14 to take a whack at, and then we'll work on those together just a little bit. Go ahead and try the problems, and we'll see what problems we need to go over.